welcome to Saturday's edition of Cracking the Cryptic, where we've got another puzzle by GDC today involving these wonderful new Sudoku lines, the so-called zipper line. There seems to be a slight rinky-dink here. It's a small grid, and the zipper line, which normally what you've got with an odd length line is that you put the digit here that is the sum of the digits that are sort of an equal distance away from the center of the line. So imagine this was a 9, which don't think it can be in this puzzle, which is a 1/6 puzzle, but just imagine this was a 9. Then those two cells would add up to 9. These two cells would add up to 9, and these two cells would add up to 9. And if you made that 8, then these two add up to 8, etc., etc. Now this puzzle seems to be different because this line, which has a diamond in the middle of it, is an even length line. So the way this works is that those two cells add up to the same as those two cells, add up to the same as those two cells, add up to the same as those two cells, etc. But with an even length zipper line, you don't know what the total is. You've got to somehow deduce it. That's how I read the rules anyway. That's all the rules. And the only other thing that's interesting about this puzzle, well, no, there are two things that are interesting about this puzzle. The first is its name. It is called Aad-van-ced Zippers, which is it's very clearly a reference to the Dutch Sudoku constructor Aad-van-ced Wetering. And I think, I suspect that's giving you a hint about how to approach the puzzle. The other interesting thing about this, though, is I've just looked it up on Logic Masters Germany. One of the testers thought this was wonderful, this puzzle, and it's been recommended to us. But it has an 82% rating, which is incredibly low. And that suggests to me that perhaps people have solved it without appreciating some feature of it. So I'm certainly going to do my best to find out and solve it logically. Perhaps you can bifurcate to a solution or something, and that is not what we're about here on Cracking the Cryptic. Anyway, this is going to be today's solving, or my attempt at solving anyway. But I've got a few things to tell you about before we kick into that. I'll start with an update from the Fog of War Kickstarter that we have going on at the moment. We're running out of days actually, but we've just passed the third stretch goal. So what this is going to be is, this will be delivered in time for this Christmas, so it's a great present. It's going to be a novella that Peter C. Hayward is busy writing, wrapped around 10 Sudoku puzzles by Sandra and Nala, which are Fog of War. If you watch the video from a couple of days ago, you'll know how fun they are. And then the artwork's Hayley Mooney, and it's just brilliant. It's $5. If there is an option to pay a bit more. I think it's $12, and for that you get all the stretch goals as well, which is and all the video solves of the puzzles. And the stretch goals include more Fog of War puzzles by, amongst others, J. Dyer, Chili, and yesterday it was announced Phistomefel. Phistomefel's first ever Fog of War puzzle is going to appear in this pack, so that's really, really exciting. And I think Peter's suggesting now that for every $5,000 the goal, the Kickstarter increases by, there'll be another puzzle added. So there's quite a chance that there's going to be a lot of extra puzzles, which is going to be fantastic. So anyway, do check that out. I'll try and remember to put a link on the screen. There is also, over on the Kickstarter, a mysterious ancient poem that has appeared. I don't know what that's about, but maybe have a look. Now, other things to mention, because there are a few. Yesterday, I did a crossword video, so if you like cryptic crossword videos, have a look at that. This morning on the channel, we released this Lord of the Rings length episode of me solving Phenomenon by Darth Paradox. I totally and utterly appreciate that will not be for everybody. But for some of you, you might enjoy 172 minutes of battle between me and the Sith Lord Darth Paradox, so that is there. That's been on Patreon now for a couple of weeks, that solve. So some people have already seen it, and we've replaced that Patreon sort of bonus with my solve of TotallyNormalCat's Broken Secrets, which has gone live today. So that's now available if you're a patron of the channel, and if you like long solves of very, very hard puzzles. It's an amazing puzzle as well. I'll put a link. If you want to play that puzzle, you definitely should have a go at it. I'll put a link under the video to that. Now, what else? Well, yesterday was the 1st of December, which means it's also Patron Reward Day. We've got the 100 Snackdoku pack. We've already had dozens of entries for that, so very well done. The idea is that these are, well, they're all 4x4 puzzles, and the idea is each puzzle is meant to take only a couple of minutes. So there's a whole series of coffee time puzzles by 50 different constructors. It's fantastic. So do check those out. Some of you, I'm no doubt, will achieve incredibly quick times for those. And then the other thing I needed to mention was some birthdays. I'm going to start off with William, who's turned 36 today. I know you're in the UK, William. I'm not sure exactly where. And I know this because Gabrielle wrote to us. And I have to say that the email that Gabrielle wrote to us, William, was one of the most fulsome bits of praise I've ever seen for anybody. Gabrielle says that you are the best thing that ever happened to her after previously a very difficult life. You're an amazing stepfather, and she loves you so much. So, William, I hope you're able to celebrate appropriately today with an amazing amount of chocolate cake. It sounds like you deserve it. Next, I've got an apology birthday. John, you turned 36, but it was back in the middle of November, and I didn't get the message until last night when I got an email from your mum, Carol, which I think had been sent to me in another way, but I hadn't seen it. And so, John, I want to wish you a very happy birthday. I hope that I know you're something of a mathematician, and I hope your birthday was great. I'm not going to read out all of the message. I'm not going to read out any actually of the message from Carol, because it was deeply personal, but I just wanted to say on the channel, Carol, that I am very grateful for your kind words, and if the videos are making any difference to anybody, any positive difference, that is a source of well, it's humbling. It's humbling to both Mark and to me, and we really appreciate hearing things like that. So, Carol, thank you, and John, happy birthday, and I'm sorry I'm late with the news. And then finally, a different sort of birthday this, to Leia, named after the princess, in Raleigh, California. Oh, not California. No, Raleigh isn't in California. It's in North Carolina. I've been to Raleigh, so I know that. And I think I've got a picture. Let me see. I do. That is Leia, who has turned 11 today. And apparently Leia, somewhat appropriately, enjoys listening to the videos, especially the Star Battle ones, which, given that she was named after the princess, seems somehow appropriate. And yeah, I know it's your birthday, Leia, because Joel and Monica wrote, and I think siblings Alison and Sarah are involved somehow in this as well. So 4 people wishing you happy birthday, Leia. I hope that you understand some of this message. I don't think you're going to be allowed chocolate cake, but I hope you have a good birthday. And that is, I think, all the news. Why don't we kick on and have a look at Aad-van-ced Zippers by GDC. And the rules are very simple. So we've got to put the digits 1 to 6 in every row, every column, and every box. And digits an equal distance from the centre of a lavender zipper line sum to the same total. For odd length lines, the total is the digit placed in the lines circled centre. Oh, I see. So this, yeah, okay. So it's those. And digits. Oh, I see. So that's yeah. So it's sort of yeah. So that deals with the even length line with a very succinct rule set. Digits may repeat on a zipper line. Okay, I'd assumed that would be possible, and I guess that's obviously going to be potentially true there. I mean, that digit could repeat there, for example, couldn't it? Do have a go. The way to play is to click the link under the video, as usual. But now, I get to play. Let's get cracking. on a very cold day here in the UK. It's going to get down to -10 this evening. Quite ludicrous. Now, how do we do this? Now, the answer is I don't know, but I am very tempted, given the title of this puzzle, to try and explore Aad-van-ced type tricks to do with set theory. Let me just think about this for a second or two, though, before we plough into set theory. Is there anything obvious at all we can say about these lines? So this digit is the sum so that's at least a 4. I think I can say that, can't I? So it's 4, 5 or 6. And that's because if this was this doesn't count. That doesn't count. It does not get a song. If I was to put 3 there, these would obviously be a 1-2 pair, wouldn't they? And then that square would have no value. Because the only way we can make digits add up to 3 is with a 1 and a 2. So, yeah, okay, so the corner is 4, 5 or 6. And if it was 4... 4 is possible. Because you could have a 1-3 pair there, and then you might say, you've got a problem with this digit, but you don't have a problem with this digit because you could do that. You can repeat digits along the zipper line, and double 2 would add up to 4, and then these could be a 1-3 pair. Again, botheration. Okay, so that didn't work as a thought. The thing is, this grid is so small, you always feel like you could colour it. Oh, that's a good thought. I've just had another thought. Nearly. 6 in row 5 was my thought. Because the one thing I know about... Well, actually, I'm going to have to revise some of my secrets here. I was about to say, the one thing I know about zipper lines is that the highest digit in the puzzle, which in this case is 6, can only go in the centre of a line. But that's not true, obviously, on this top line. Where all we're saying here is that those two add up to the same, those two add up to the same, those two add up to the same. So you could, for example, if you had 6 and 1, if that was 6 and 1, well, no, if that was 6 and 1, that would add up to 7. So these could be 5 and 2, and that would be fine. The 6 would very much not be on the central domino of the line. But 6 in this row, I thought it was going to be restricted, but it's got 2 cells, hasn't it? This line is a lot less useful than the classic zipper line. Okay, all right. So let's trust GDC's title. Now, there is something that comes up in normal sized. There is a trick that Aad-van-ced invented that happens in normal 9x9 Sudokus that, well, obviously it doesn't apply in 6x6, but I can see how I could replicate it a bit by looking at those 3 rows. So if I just highlight those cells for a moment in yellow, and then I'm going to highlight these in, should we do those in blue? And then those I'm going to cancel out. I don't know. I'm not quite sure where this is going, but I'm going to explain what I think we're being asked to think about by the title of the puzzle. So the yellow cells are clearly... We don't know how the digits are disposed within these yellow cells, but we can describe the contents of those yellow cells absolutely precisely, because in total we know that this is 3 complete rows of the puzzle. So the yellow cells in total contain 3-digit 1s, 3-digit 2s, 3-digit 3s, all the way through to 3-digit 6s. Now, the blue cells, we can describe the contents of the blue cells precisely. That's going to be 2-digit 1s, 2-digit 2s, 2-digit 3s, because this is 2 complete columns of the Sudoku. So the difference between the yellow cells and the blue cells, ab initio, is 1 set of the digits 1 to 9, because this has 3. The yellows have 3 of everything, and the blues have 2 of everything. Now, if we were to remove this cell from both the blue and the yellow set, how does that change the difference between the remaining yellows and the remaining blues? Doesn't change it at all, does it? It's still true to say that what's left in yellow must differ from what's left in blue by one set of the digits 1 to 9, because we've taken the same thing out of yellow and blue. So the difference must still be the same. We can obviously repeat that for all of those cells that are sort of that are bichromatic. So what we get is sort of a 6x6 version of the Aad-van-ced Wetering trick, where the difference between yellow and blue now is one set of the digits 1 to 9. So I'm going to remove those cells, because box 1, that clearly is one set of the digits 1 to 9. So if I remove those, now yellow and blue are the exact same digits. And the thing is, we don't know what those digits are. And this line isn't quite covered, is it? So we've got 6 digits here, 6 digits there. These are the same digits. This one, we don't know. We almost don't know anything about it. We know that it's a multiple of 3. We know that the sum of these digits is a multiple of 3. So they could be, I wonder whether we're being led to the conclusion that these digits are all different. Because 1 plus 2 plus 3 plus 4 plus 5 plus 6 is 21, which is divisible by 3. How do we know these are divisible by 3? Well, we know these two squares, let's call the value of those two squares x, add up to the same as those two squares, let's call that x, that's 2x so far, add up to the same as those two squares, so that's 3x. So those yellow squares add up to 3x, so they're divisible by 3. The total of them is divisible by 3. So this is divisible by 3, but we don't know what that one is, which feels like it's a problem to me. Hang on. How do we do this? If this is, can we even get rid of 4 now? If that's 4, that's 4. There've got to be 4 different digits, but there would be, wouldn't there, with the 4132 thing that we were talking about. That's 4. That's 1, 3. That's 2. That's 2. So we'd have to have 2. We'd have to have 2 in here and a 2 in here. We couldn't have a 2 there because there could only be 1 2 on the yellow line. Yeah, and that would put a 2 by Sudoku on this line, and that would work. Is there... I just wonder if there's a parity thing going on here. Let me think about that. So if that's... Because I suppose... Well, the reason I'm thinking about parity is obviously... this sort of losing the power of speech. But it must be true to say... Or am I wrong, actually? Hang on. Hang on a minute. Am I wrong about that? Sorry. I might be wrong, mightn't I? Bobbins. Oh, Simon. Okay, sorry. I am still a bit nonplussed by this. I think there's something going on. I just don't understand quite what it is, I'm afraid. Is there some point about this being divisible by 3? If this is... Hang on. Okay, yes, there is a point, isn't there? Yeah, okay. What I hadn't considered about this is that those squares are divisible by 3. Oh, that's beautiful. That must be... Oh, that's sick. Oh, it's simple. It's simple. And I just didn't... I was thinking about it in a different way, and that was a silly way to think about it, and I should have been thinking about it in a sensible way, and I've let everybody down, including myself. Bobbins. Okay, but the whole point is that that's divisible by... well, that's 0 mod 3. What do I mean? Well, the yellow cells are divisible by 3 in total. The blue cells are divisible by 3 in total. But the nature of this line, this is an odd length line, so let's call this cell x. That's x. Those two squares must add up to x. These two squares must add up to x. So this portion of this zipper line is 3x. So it's divisible by 3 perfectly. So what must this be in order to ensure that this whole line is divisible by x? Well, this square has to also be divisible by 3. Well, it's not 1, 2, 4 or 5 then. And how could it possibly be 6 on a zipper line? Because if it's 6, 6 plus this digit add up to that digit, which can't be bigger than 6. So that is a 3. That is beautiful. GDC is a brilliant setter. That is just beautiful. Ah, now, okay. So what does that mean in terms of... Does that mean this is a 4? Oh, well, one thing it means is it's not a 6. It's not a 6 because that would be a 3, because those two would have to add up to 3. So this is... Right. So that's powerful already, because where's 6 in this column? It can't appear on the line. So 6 is at the top there, and now where's 6 in this column? Well, it can't appear on a line unless it's in the middle, and it can't appear in box 2 anymore, so that's a 6. So there's a 6 down here. And this square, which is either adding up to 4 or 5, is 1 or 2. And that feels like it might be important, doesn't it? So if this is 4... If this is 4, this is 1. That would have to be double 2. This would be a 3. This would be a 1. And what are we left with up here? A 4-5 pair or something. Oh. Oh, I see. No, this is not. That's nonsense. No, it's much easier. If that's 4... Where do you put 5 in this column? And the answer is up there. And if this is 4, where do you put 5 in this column? And the answer is up there. And I can't put 2 5s up there because that will break the rules of Sudoku. Oh, this is just... I think there was an easier way to see that. I just didn't spot it. So that's a 2 now to make this add up to 5. Now, what does that mean? This square... Yeah, these two squares, look, have to add up to 5. So they're either 1, 4 or they're 2, 3, but this can be neither. It can't be either 2 or 3, so that must be 1 or 4, which means this must be 1 or 4. And now this can't be a 1, 4 pair because that would break this square. So this must be a 2, 3 pair. This is breathtaking. Who is solving this and not thinking this is breathtaking? This is just beautiful. It's absolutely beautiful. Right, what does that mean? Oh, I know what we can do now. So now we know what the total of those blue squares is, and it's 18, which means that we know the total for this line, or the total for the yellow cells, which, remember, the yellow cells added up to 3x is 18. So this line, every pair on it adds up to 6. Which means these add up to 6, which means they must be 1 and 5, because they can't be double 3, and they can't involve a 2. So these squares are 3 and 4. Oh, that's fine, isn't it? So we're going to have a double 3 somewhere. So either that's double 3, or that's double 3. This must be 1, 4 or 5. Okay. What does that mean? Is this, have we sort of... here's another thought then. So these squares, all in box 1, we know that those two add up to 6, and these two add up to 6. And again, double 3 is not an option within box 1. So these must be 1, 2, 4 and 5, which means these squares are 3. This is good. That's 3 and 6, which means that's a 6 in the corner. So this is a 1 or a 4. It means that this is a 3, which means this is a 2. We know 3 goes opposite 3 on the line. So let's get this right. I think that's a 4, and that's a 3. So this is not a 4, so this is not a 2. This is not a 2, so this is not a 4. That 3 means this is a 1, so that's a 4. This is a 1, 5 pair. This is a 4, 5 pair. And that's probably that. Yeah, well, no, actually. No, if that's not 1, what are we saying? That's not... No, hang on, I've got to be oh, hang on. Hang on a minute. I think I've made a ricket there. Let's go back. Because... No, I was fine here. But... Let me see, did I make a... Yeah, I did. I suddenly realised... As I was thinking about this line, I took 4 out of this square, and look what I did. I took 2 out of this square. That's wrong, isn't it? Because if you take 4 out of this square, you have to take 2 out of the one that pairs up with it. I should have coloured this line. That's what I should have done. I should have done that and that or something. And that's going to make it easier for me to not make rickets. So if that's not 4, that's not 2. And if that's not 2, that's not 4. Okay, the 3, 6 still does unwind this as a 1, which does give me a 4 here. This is a 4, 5 pair. That is not a 1, and that means I take 5 out of this square. Okay, so... Oh, bother. I don't know. This must be resolved somehow. How does this resolve? These are 1, 5. This is 4, 5. These... Oh, I must know that now. 2 and 3, that's a 1. So this combo is a 4, 6 pair. And this square, okay. So this zipper line is probably where we look now. And that square can't be 3 or 4, look. And it certainly can't be 2, because I can't put double 1 on the line. So this is 5 or 6. And it has got 2 in one of those positions. So, wow, that's lovely. That is absolutely beautiful. So this is not 6. It's not 6 because of this delightful creature, which is called 4 in this puzzle, but is actually just plain beautiful. Because how could that be a 6? If that's a 2... Where are we putting 4 on the line to add up to 6? There, and that one stops it. And if that's a 2, where are we putting 4 on the line? There, because those two add up to the same number. So if that's 2, that's 4. If that's 2, that's 4. There's a 4 in one of those, and that 4 rules out both of them. So we have to put 5 in here, which means that's not 5, which means that's not 1. So I get a 4, 5 pair here. Now the digit that's opposite the 2 is a 3, so we can't put 2 there because that would be a 3. So this must be 2, that must be 3, that's 3, that's 6. This is 1 or 2. This square must be a 1, 4 pair, mustn't it, to add up to 5, and it can't be 1. So that's 4, that's 1, that's 2, that's 2, that's 1, 2 goes with 4, that's 5 in the corner, 5, 4, 5 here, 1 here, 5 here, 6 here, 1 here, 4, 4, 6, 6. That is breathtakingly clever. Breathtakingly clever. Loved it. Aad-van-ced Wetering has a lot of things to answer for in Sudoku, not least having created probably the most famous Sudoku of all time. But the fact that other brilliant constructors can take ideas like Aad's and make something so utterly exquisite. That's such a lovely puzzle. Geometry, a little bit of maths, and it just falls, doesn't it? It just falls. I absolutely adore that. GDC. Take a bow again. Keep. And these puzzles, I love them because they're like an extended version of a Snackdoku. It is like a slightly bigger version of a Snackdoku. You have to give it a bit of thought to do anything. But once you have the right thoughts, they all slot into place in such a gorgeous way. Oh, I loved that. Let me know. I hope loads of you had a go at that. Let me know in the comments how you got on. I enjoy the comments, especially when they're kind. And we'll be back later with another edition of Cracking the Cryptic.